Today, we're diving into something pretty fascinating. It's a tool that helps us make sense of a world that, let's be honest, isn't always black and white. We're going to talk about fuzzy regression analysis, which is really just a powerful way to model all the uncertainty and, the vagueness we find in everyday data.
I mean, really think about that for a second. We love measuring things with perfect, exact numbers. But is that really how we experience life? When you talk about the weather, or a business trend, or even just how you feel, do you always use a precise number? I'm guessing probably not. And that right there, that's the core problem we're going to tackle. So here's how we're going to break it all down. First, we'll look at why data gets so vague in the first place. Then, we'll get into the brilliant idea of fuzzy logic. From there, we'll see how that applies to regression, how we can actually model with words, which is so cool. And finally, we'll zoom out and see what this all means for understanding our very uncertain world. Okay, so before we jump to the solution, let's really get a handle on the problem itself. And that problem is the vagueness that's just baked into the information all around us.
This comparison pretty much says it all, right? On one side, you have crisp data. It's precise, it's a number, it's exactly what traditional computers are built to handle. But on the other side, you've got fuzzy data. Warm isn't a number, it's a concept. It doesn't have these super sharp edges, but we all instantly know what it means. And this is the kind of information that classical models really struggle with.
So, how in the world do we build systems that can understand a word like warm? Well, that brings us to our second part, and to the big idea that kind of changed everything: fuzzy logic. And, this isn't some brand new, flashy concept. This goes all the way back to 1965, when a computer scientist named Lotfi introduced something called fuzzy set theory, specifically to handle this kind of vagueness. A decade later, he built on it with this idea of linguistic variables. And today, these concepts are absolutely fundamental for building smarter, more intuitive AI.
So what's the secret sauce? Well, classical logic says something is either true or it's false. You're either in a set or you're not. But fuzzy set theory throws that out the window and introduces this incredible idea of degrees of membership. An item can be partially in a set. So a temperature of 25 degrees might have, say, a 0.8 degree of membership in the set we call warm. It's kind of warm.
Honestly, here's the best way to think about it. Classical logic is just like a standard light switch. It's on or it's off. 0 or 1. End of story. Fuzzy logic, though, it's a dimmer switch. It allows for all the possibilities in between. 20% on, 75% on. It perfectly captures that nuance, that gray area, of the real world.
All right, so we have this powerful idea of fuzziness. Now, how do we actually employ it to one of the most common statistical tools we have, regression analysis? Okay, this is the big aha moment. A traditional regression model tries to draw one single perfect razor-thin line through your data to make a prediction. But fuzzy regression, it knows that reality is, fuzzy. So instead of a sharp line, it creates a band of possibilities. It gives you a range of potential outcomes. It's like a model that has a little humility built right into its DNA. So why would you want to do this? Well, because it's incredibly powerful. It lets our models actually understand natural language. It helps them embrace the ambiguity that you find in any complex system. And instead of pretending it can predict one single exact future, it gives us a much more realistic range of what might actually happen. And this leads us to one of the most exciting applications of all. Let's dig into how this lets us build models that can actually reason using human language. Remember that term from the timeline, linguistic variable? Don't let the fancy name scare you. It's just a variable that uses words instead of numbers. So instead of having to input 25.1 degrees, you can just input the word warm. This is an absolute game changer for making our interactions with machines feel more natural. And here's what that looks like in the real world. You can create these simple, intuitive rules that make perfect sense. The model takes an input, like demand is high. It then applies a rule that you created. If demand is high, then inventory should be large. And the model's job is to translate that word large back into a useful range of numbers that you can use to make a real decision. And the takeaway here is just massive. This isn't just some neat technical trick. This is a huge step toward making AI less of a black box, By using rules that we can all read and understand, we create models that are way more transparent, more interpretable, and in the end, a lot more trustworthy. Okay, for our final section, let's zoom all the way out. Because fuzzy regression is really just one piece of a much bigger puzzle. the entire scientific effort to model and manage uncertainty.
Yeah, it's really important to see that this isn't just some one-off technique. It's part of a whole fuzzy toolkit. You've got things like soft clustering, where a single piece of data can belong to a few different groups at once. You've got fuzzy numbers, fuzzy measure theory, all these incredible tools designed to help us navigate a world that isn't always neat and tidy.
And look, if you take just one thing away from our whole chat today, let it be this. For centuries, science tried its best to eliminate vagueness, to get rid of it. Fuzzy logic does the exact opposite. It gives us a rigorous mathematical way to work with that vagueness, and that leads to models that are often way more robust and a lot more realistic.
So, I'll leave you with a question to chew on. As our AI systems get more and more powerful, and we ask them to solve these incredibly complex, real-world problems, maybe the most important skill we can teach them, and frankly ourselves, isn't about finding the one single perfect answer, but about learning how to gracefully and intelligently master uncertainty. Thanks for tuning in.